In this video, we will find the total volumetric strain of a round bar. That is, the round solid circular bar is there of certain diameter and its length is L. Okay. So in this case, we need to calculate the total strain or volumetric strain developed in that bar, and it is always the sum of the longitudinal strain and the twice the lateral strain. That is, we know that if suppose a solid bar is there, if it is having the diameter D and its length is L, in this case the total strain is, we have two types of the strains. One is longitudinal strain due to the length, one is the lateral strain due to the diameter, lateral strain. So we need to prove that the total strain or volumetric strain is equal to the sum of the longitudinal strain and the twice the lateral strain. That we need to derive here. That is, the headline is volumetric strain in a round bar. In a round bar is sum of longitudinal strain and twice the lateral strain. Twice the lateral strain. Okay. We will go step by step here. That is, first we will consider a round bar. That is a round bar. It's having a diameter D and its length is L. Its length is L. Okay. Consider a round bar, a round solid bar of diameter D and length L as shown in figure. Okay, we will start deriving the equation by taking the volume of the round bar. Okay, we know that volume of bar equal to V equal to, what is the volume formula? Pi d square by 4 into length. Okay, that is pi d square by 4 into L. That is area into length. Okay, take the log on both sides. Taking log on both sides. Both sides. If you take the log on both sides, what will happen? Log to the base E B equal to log to the base E pi d square by 4 into L. Okay. This we know that log A into B is log of A plus B. That formula we need to apply. I will apply here log to the base E pi by 4, okay, plus log to the base E d square, okay, d square, plus log to the base E L. Okay, I just split it, applied the equation and splitted that one. This is log to the base E V volume. Okay. Now differentiate partially on both sides. Okay. Differentiate partially on both sides. Okay. We need to make the partial differentiation. That is, what we'll get here, 1 by V, the partial differentiation of the log V is 1 by V into dou V, equal to the partial differentiation of log to the base e pi by 4 is 0 because it's a constant, plus this one, this I can also write it as here 2d 2 into log to the base e, right? Log to the base e into d. This just the next equation. This I can write it as plus 2 into 1 by d, that is dou d, right? The partial differentiation of log to the base ed is 1 by d into dou d, plus what is the partial differentiation of log to the base el, that is 1 by l into dou l into dou l. Okay, so this, after simplification, I will write dou v by v equal to 2 times dou d by d plus dou l by l. Okay, so what is this one? That is change in volume divided by original volume. Change in volume divided by original volume is the volumetric strain, right? That is volumetric strain, that is the epsilon of v. Volumetric strain is nothing but change in volume divided by original volume. Similarly, I can write it this one as 2 times change in diameter. Change in diameter divided by original diameter is, that is the strain in diameter, plus change in length divided by original length is, that is strain in along the length, along the axis here, along the axis. This how I will write here, that is volumetric strain. This is total volumetric strain, change in volume divided by original volume is 2 times. Can I write this strain in diameter is lateral strain because it is lateral, it is along the lateral direction. So I'll change this one as strain along the lateral direction, plus this straining along which direction? Along the length here, that is longitudinal, along the longitudinal. So this is how the equation. Therefore I'll write the total volumetric strain, the volumetric strain equal to sum of, that is sum of longitudinal strain, that is longitudinal strain, and what? And twice the lateral strain. This is the proof. So always remember, in solid circular bar with diameter d and length l, the volumetric strain is the sum of the longitudinal strain plus twice the lateral strain. Okay.